thank you for your patience. Discord gets temperamental from time to time.
Mr. Strickland is back with a vengeance.
Back with a vengeance. Alright, so, what do I want to say? Squares, and I'm not talking about, to the power of 2, like squares like that. Squares and rectangles. Squares are a certain unique type of rectangle, right? It's a rectangle where the sides are the same. Circles are a unique type of ellipses. Plus y squared divided by b squared equals t. So here blue is an ellipse, but it happens to be a circle. But if I change these numbers, now I've got an ellipse, right? Something nice and elliptical, right? An ellipse is kind of like a compressed circle where you stretch it in one direction or another. And also, yeah, you can make it bigger. It can be horizontally oriented or vertically oriented, right? So these are ellipses. And the special thing about ellipses, so a circle has a center, an ellipse also has a center, but that's not the interesting part. So let's see, negative square root a squared minus b squared, comma 0, wait, so not correct, a squared give me 1 second, y'all. Oh, t is 1. Cool, there we go. And then we want positive. An ellipse has 2 foci. These are the focuses. When it's a circle, the focuses are one and the same. Notice they're in the center. But as soon as I change one of these numbers, the foci go away from each other. So, just like a circle is a collection of all the points that are the same distance from the center, an ellipse is a collection of all of the points that, when you take the distance from focus 1 to the point and add the distance from focus 2 to the point, this distance is always constant. And I'm going to make a drawing here. So let us go back to the chalkboard. So I'm going to draw just a ellipse here. It's going to be horizontally oriented, slightly egg-shaped, very squished egg. I'm going to draw the 2 foci, or where I would expect they would be. Don't expect this to be a perfectly accurate drawing. So I'm going to pick 1 point on the ellipse. So let me label these. This is focus 1 and focus 2. So the distance from point, let's call this point P to focus 1. Let's call that A. And point P to focus 2, let's call that B. Goodness. Let's make a better A here. So, point P, goodness, my dog is crazy, y'all. So I'm going to make another point. I'm going to call it point Q. Let me do this instead of white, but I can do green. Call this point Q. So the distance from point Q to F1, let's call that C. And the distance from point Q to F2, let's call that D. So the key to the ellipse here is that A plus B is equal to C plus D. That is what an ellipse is. Do you have any questions about this, or does this make sense so far?
Does Q have to be in a specific place, or just
Nope.
any
Could be
4
here,
points?
here, here, anywhere on this ellipse, this purple ellipse.
Just any 4 points.
Yeah, any 2 points on the purple ellipse, when you take 1 point and you take the distance to focus 1 and add the distance to focus 2, it is the same as the other point when you take the distance to focus 1 and add the distance to focus 2. Any pair of points. And I'm going to show you a video too. So let's see. This
So are
is
ellipses
yeah, this
like
is new
plotted
material.
in pairs of points?
Yeah. So the graph of an equation is all of the ordered pairs that satisfy the equation, right? And the equation is predicated on the sum of the distances must be the same. So these are all of the points. So say the distance to focus 1 is 1 unit and 7 units. So really we're talking about 8 units. And this, the distance to focus 1 might be 6 units and focus 2 is 2 units. So really we're talking about 8 units. When you take the addition, it's always the same number.
Okay, so would any other numbers that add up to 8 also be a point that could be plotted with that same line, I guess?
Yes, not the numbers that add up to 8, but when you take the distances and you add them, if those distances add up to 8.
Okay.
Does that make sense?
Yeah, so that 8 number can be anything.
And that will change the size of the ellipse.
So that's why it's so many
It's
points.
kind of like
Okay.
the radius for a circle, but it's not really a radius, but it is about the size of the ellipse. I'm going to show you a video, let's see, of how you draw an ellipse, and I think this will be really natural, how to draw an ellipse. Okay, so let's go to YouTube here. Okay, so you see these 2 toothpicks. These are representative of the foci. He's going to take a string that has no elasticity whatsoever. The string does not stretch. And he's going to put it between the 2 toothpicks. And the string is a little longer than both the distance between the toothpicks. So see, you have this leg of the triangle and this leg of the triangle. And he's going to put the marker at this point where he's pinching with his thumbs. And so that's going to ensure that this distance always stays the same, because this distance between the toothpicks, it is not changing. But this leg and this leg, they are always changing, but their sum is still the same. Because imagine if this is 10 inches of string, currently if it's 8 inches of string and then 2 inches of string, over here it's going to be more like 4 and 4. So watch as he draws the ellipse. So right now it would be more like 4 and 4. Watch how those legs change.
What, mate?
And so the further apart the foci are, the more elliptical we get, the more stretched we're talking about. We're not doing Desmos. Okay. So does anybody have questions about ellipses? I'm about to show you all the anatomy of an ellipse.
Can you put that?
You want the link?
Yeah.
I got you. It's 53 seconds long for some reason, and the music is quite interesting as well. So
Oh, you already put this up there. Okay.
yeah, I did. So let me just draw an ellipse, and we're going to talk about all the anatomy points of an ellipse. Let me try a little better. That's acceptable. Alright, so an ellipse has 2 axes. The longer one is called the major axis. In this case, it's horizontal. So this is the major axis. The shorter one is called the minor axis. If the major axis were vertical, then the ellipse would look more like that, instead of wider than it is tall currently. So this is the center of the ellipse, and I'm going to assign a few letters. We're going to call this distance, well, okay, so on the minor axis, you have, well actually, so let's do the major axis first. On the major axis, you have what we call the vertices. Each of these is a vertex, these endpoints of the major axis. And this distance is A units. So the length of the major axis is actually 2A units. Now, the minor axis, we call these endpoints the co-vertices. This distance is B units. So actually, the length of the minor axis is 2B units. Now, we're going to have our foci. The foci always lie on the major axis. So that means, so this one's horizontally oriented because the major axis is with the x-axis. So the foci are going to be somewhere in here-ish. I'm going to call this focus 1, and I'll call this focus 2. Furthermore, this distance is A units as well. So notice, half of the major axis is A units, and also the distance from one focus to any point on the ellipse is also A units. These are the same length. So notice there's actually a triangle going on here, and by the way, the focal distance is C units. So we have a right triangle here. We get A squared plus B squared equals C squared. So let's write that down. Plus B squared, A squared equals B squared plus C squared, because A is the big one, that's the hypotenuse, right? So unfortunately it's actually backwards from the Pythagorean theorem, kind of, so that's kind of sad. So A squared is the sum of these two guys. The hypotenuse is the sum of the squares of the other ones. So, and let's actually give names to A, B, and C. So A, well, I mean, I don't know if I would give them names, but A has to do with the length of the major axis. I mean, it's right here, right? And B has to do with the length of the minor axis. So as A and B will change, also the focal length will change. Notice I've only drawn one quadrant here, but this triangle is also happening over here too. You can reflect it. And that is true of any pair of points, any point on the ellipse. Do you guys have any questions about ellipses?
So what would be the distance from like F2 to that co-vertex? Is that still going to...
Yeah, that's A. That is also A units. The distance from focus 2 to any point, well, sorry, not to any point, but the distance from focus 2 to some point, right? Remember, the sum of the distances are the same, but from the foci to the co-vertex on either side is A units.
Oh, but that wouldn't be true if it wasn't a co-vertex.
Right. So here, it would. So notice this adds up to 2A. So these legs would have to add up to 2A, but it's not A and A. It might be like A divided by 4 and 3/4 A.
Gotcha. Thank you.
Mm-hmm. Good question. All right. Any more questions about the ellipse? This is all the anatomy of an ellipse, which seems a little complicated, but it's not too bad, I promise. And so I'm not going to bother drawing a vertical ellipse. You just rotate everything, right? So no big deal. Let's talk about the equation of ellipse. I actually I haven't even had my notes out this whole time, so let's get those out. I got too excited, y'all. Well, I know the equation, so. This,
That music from that one video is stuck in my head.
yeah, it's kind of strange music. So, for an ellipse centered at h comma k, just like circles, we have x minus h quantity squared divided by a squared plus, remember that's to do with the major axis, plus y minus k squared divided by b squared. And remember, b has to do with the minor axis. So since I have paired a and x, that means that I've already dictated a horizontally oriented ellipse. So if a were with y instead, then it would be a vertical ellipse. So a squared is always the bigger quantity. Whichever fraction has the bigger denominator is the major axis. So this happens to be in a horizontal ellipse, but if I want it to be vertical, I just switch a and b. So let's see, what do I want to do? So let's see. I want to leave that there so we can see it. Let me box it. Cyan always kind of hurts my eyes. Maybe I should stop using it. So let's write the equation of an ellipse centered at -3, 7 with a minor axis 6 units long and vertex, one of the vertices, just one of the vertices, there's 2 vertices, but one vertex is given, and that vertex is -3, 1. Okay.
Just really quick, for a vertical ellipse, do you just have to switch like the x and y variables, or do you switch the like x and y numerators?
So whichever of the fractions has the bigger denominator, that's the orientation. Does that answer your question?
I think so. Okay.
So you can switch the orientation just by switching a and b or switching x and y, but you would not. Yeah. If you switch x and y as they are inside, you change the center. So don't do that. Good question. So a lot of these are going to be given to you, and you know, I have trouble imagining what this looks like. So I would always suggest drawing a picture. So let's draw a picture here. The center is -3, 7. I'm just going to eyeball it. And the minor axis is 6 units. I don't really know which direction that is yet. And the vertex is at -3, 1. So that would be along the same lines. It's -3, 1 and -3, 7. It's just my handwriting is poor because it's so small. So here we have the center. I'll label it. And here we have the vertex. So does the vertex have to do with A or B? Well, the vertex has to do
with -3, 1.
Oh, thank you. I have it backwards, don't I? So the vertex relates to A, and the co-vertex relates to B. And remember, the major axis is 2A units, and the minor axis is 2B units. Well, actually, that's pretty helpful. Earlier, we said something about the minor axis, didn't we? So I want green. There we go. We said something about the minor axis. Well, it's 6 units long, so B must be 3. And by the way, I should have written this down a moment ago, but to find the equation of the ellipse, you always need the center, A, and B. Nothing else. Do we already have the center? Yes. We just found B. Now we have to find A. So A either has, well, it has to do with the major axis, or if we have a vertex, we can find it. So the vertex is located here. The distance between the center and the vertex is A units. So what's that distance? Well, it's 6 units. So A equals 6. So B, the minor axis is always 2B units long. The problem told us that the minor axis was 6 units long, so 6 equals 2B. That means that B equals 3. Is that good, Graham? Is everybody comfortable with how we found A and B just now? How did you find A? A is the distance from the center to the vertex. And those are, just graphing them, I can see that they're 6 units apart. Yeah.
Wait, I'm still a little bit confused. Why do you have the, is the center at, like, the top?
Yeah, this is the center. Let me make bigger points. So this isn't the entire ellipse. If I wanted to draw the entire ellipse, it would look something like this. And I'm going to erase this after I draw it, but the entire ellipse would look something like this. Does that make sense?
Oh, wait. Okay, so your 2 lines is just a graph. I thought that was the ellipse itself.
Oh,
like
it's not, yeah.
Center being a center point. Okay.
This is the ellipse. I just didn't draw it. I'll just keep it there. You have a question, Graham? So we have the 3 pieces of information we need. Yes, exactly. The distance between the vertex and center is always A. So let's go back to the picture. The distance between the vertex and the center is always A. And likewise, the distance between the co-vertex and the center is always B. Always, always. And the co-vertices and vertices will switch locations depending on the orientation. Cool. I know this is a lot, but it's going to be easy real soon, y'all. So now we have the center A and B. So I have my equation over here. So I'm going to write the equation. It's kind of crowded, but I'm going to write the equation in pink. Since the minor axis is 6 units long, B is half of the minor axis. The minor axis is always 2B units long. So I get x minus -3, so x plus 3 squared. I'm using this ordered pair, right? That's the center. Plus y minus 7 squared. So x, so it is vertically oriented because the vertex is below the center. If it were left or right of the center, it would be horizontally oriented. So since the vertex are top and bottom, I know it's vertically oriented. And if it's vertically oriented, that means that A goes with Y. So if A goes with Y, yeah, 1 minute. So A goes with Y, that's 36 squared, and B, A squared is 36, and B goes with X, so it's 9. So the reason I know A goes with Y, the bigger denominator has to agree with the orientation. And I know this is vertically oriented because the vertices are above and below the center. If they were left and right of the center, I would know it's horizontally oriented. The reason we have vertices and co-vertices is because the vertices are the ones that are farther out. So the equation told us the one that was farther out, so by telling us the vertex was below the center, we knew that it was vertical. Does that make sense? Okay.
Can you go over how you found A and B again?
Yeah, for sure. And of course equals 1. So you're comfortable with my picture, right? A is the distance from C to the vertex, from center to the vertex. So that's how we got A equals 6, because the distance from -3,7 to -3,1 is 6 units down. Right? The distance to A or the distance to B will always be completely vertical or completely horizontal. You don't have to use the distance formula. You can just count the grid points or just count the difference, right? And so it tells us that the minor axis is 6 units long. So in other words, this is 6 units from one co-vertex to the other. And the distance from co-vertex to center and co-vertex to center is 2b. So by telling us the actual entire minor axis gives us 2b, so b must be half of that, or 3.
Okay, that makes sense. Thank you.
These are really good questions, y'all. Are y'all all on board with this? Are we happy?
Yeah.
Cool, because I think on the other class I kind of blew through this, especially because I had an appointment after class. So I think they're having probably a hard time right now with the homework. So let's okay, cool. So I'm going to give you an example problem. So please find the equation if, let's say, vertices at 2, 6 and 8, 6, and also, let's say, what do I want to say? Let me make these the co-vertices, and I'll also give you a vertex is at, let's see, 5, 13. So find the equation. Remember, for the equation you need center, A, and B, always. The center is not given, you'll have to ascertain it somehow. I think you'll figure it out. A has to do with the vertices, and B has to do with the co-vertices. I'm gonna go over to my picture really quick, Graham. So the co-vertices are just like vertices, it's just that they're on the shorter axis. Does that answer your question? I'm gonna go get some water, y'all. I'll be right back. Gotta stay hydrated. And please let me know as soon as you finish. So when most people finish, I can go over the solution. Otherwise, I'll just be staring at my wall. That's not as entertaining as teaching.
So okay, so co-vertices are the top and the bottom, I think, right?
Co-vertices are aligned with the smaller axis.
Yeah.
So
the
earlier,
minor axis.
if you take a look at my picture, the only reason the co-vertices are top and bottom is because it's a horizontal ellipse. If it were a vertical ellipse, the co-vertices would be side to side.
Yeah, side to side. Mm-hmm.
Cool.
So it's a hard one.
Okay, so how do you tell which, like, how it's oriented again?
So the bigger, whichever's bigger between A and B, and y'all probably want this equation as well. Whichever's bigger than a and b has to go with the same variable along which it's oriented. So if if it's horizontal, then a goes with x. If it's vertical, then a goes with y.
Okay.
Uh-huh.
Vertex is the middle, right, or no?
Nope.
Oops, it's the longer, right?
Yeah.
One of the longer.
Vertex is the end point of the major axis.
Okay, so we're just trying to find the other endpoint.
You can find it, but you don't need it.
Okay.
You guys are doing great, by the way. I love all these questions. I can't believe, like, I think back to high school and I had teachers that didn't like when we answered questions or lots of questions. And it's my favorite thing to do is answer questions, even when they're off topic. So,
Thank you. I think I know where the other thing is, but I don't need it. It's just like...
are we still working? Has anybody finished? If you finished, please let me know.
I think I finished.
Mira finished. Give you guys probably 30 more seconds. We're done. We're done here. Alright, so let's draw a little picture. You can print out graph paper online, by the way. If you have trouble with that, let me know. Or you can just print out my worksheets because they have grids as well. So co-vertices 2, 6 and 8, 6. That means that this is the minor axis. So we must be talking about a horizontal ellipse. The center has to be between these guys. Whoops, I did it wrong, didn't I? 8, 6 would be more over here, and 2, 6. Yeah. Sorry, I'm nuts. 2, 6, 8, 6. So this is the minor axis, so it must be vertically oriented. So if you are given the pair of either co-vertices or vertices, then you can ascertain the center, because the center has to be directly between these guys. Well, the length of the minor axis is 6 units. So it must be 3 units either way, and to add 3 units gives me 5, 6. So that's the center, 5, 6. And since we have the minor axis, that's B, is 3 units. Now I just have to find A. And so A, so my vertex, these are co-vertices. And my vertex is up here at 5, 13. 7 units above the center. So that means that A must be 7. Now we have everything we need. And also, if you just happen to want to sketch an ellipse, this is how you graph an ellipse as well. We're not really going to talk about graphing ellipses, because even doing these problems, you have to graph the ellipse, if that makes sense. So 5, 6, 7, and 3. So I'm going to write my equation here in pink. So I get x, that's not pink, but we'll go with it. X minus 5 quantity squared. X gets b because it's vertically oriented. That means y gets a. So x gets b squared, that's 9, plus y minus 6 quantity squared divided by 49 equals 1. Any questions here? Let me make a new page here. Why don't you guys go take a 1 or 2 minute break? Go stretch them legs, get a drink, pet your pets. What's your question, Arshia? I'm not sure I understand your question. Yeah. If it's horizontal, A goes with X. If it's vertical, A goes with Y. Alright, let's get started. So we got co-vertices at 1, 3 and 1, -1. Let's draw a rough picture here. 1, 3 would be roundabouts here, and 1, -1. These are the co-vertices. So this must be the minor axis. If that's the minor axis, then we must be talking about a horizontal ellipse. We need the center, A and B. Since we have a pair of co-vertices, the center should just be in between, so no problem. Let's go ahead and find the center. Notice these share the x-coordinate, so the center also has to have the same x-coordinate. It will be halfway between 3 and -1, which is 1, 1. And so co-vertices gives us B. B must be 2, because B is the distance between the center and the co-vertex, or it's just half of the entire minor axis, which is 4 units. So B has to be 2 units. Now we just need to find A. There's one piece of information we haven't used yet, and that's where the focus is. So let's go, I guess the focus should be at 5, 1. That's what happens when you try to make a problem exclusively in your head because you failed to prepare. Okay, so we got our focus over here at 5, 1. So this gives us the focal length. We could draw the other focus, but we really don't need it. So the focal length is the distance from 1, 1 to 5, 1. So focal length is 4 units. Well, that's C. C is 4 units. And let me go ahead and just roughly sketch this ellipse. So wherever the major axis ends, it has to be after the focus. The foci always lie within the ellipse. So now we're only missing a. We have that Pythagorean theorem from earlier. A squared equals b squared plus c squared. So a squared must be 4 plus 16. So a equals root 20. This simplifies, but I'm not going to simplify it, and you'll see why. So now we have everything we need. I'm just going to go ahead and write my equation. So I get x minus 1 squared. It's horizontal, so a goes with x. A squared is 20 plus y minus 1 squared divided by b squared is 4 equals 1. Any questions about what just happened? So it's just like earlier, we were given a pair, so we get the center, and the only difference now is that we were given the focal length, so we actually had to consult this equation. Yeah. Focus is singular, foci is plural. Sorry if that wasn't clear earlier. Cool. Okay. So, what am I going to do?
Is the equals 1 standard to put in your equation?
Yeah. You could write this as x minus 1 squared plus 5 y minus 1 squared equals 20. It's correct, but this tells you more. That's why we like this form.
Okay.
Does that make sense?
Yeah.
Great question, by the way. So I'm going to give you an equation.
Wait, scroll up for 2 seconds.
What can you
Please take a
can you
screenshot.
see what you did? Wait, so what'd you do?
To find what?
Like for the form at the bottom?
It's irrelevant.
Oh, okay.
Gary just had a unique question. So we like the yellow one. The red one's technically correct, but
The yellow one's just better.
if you don't make this 1, then it's very difficult to tell what A and B are. So, and we'll actually see that later here in a minute. So, I'm going to give you an equation. I want you to find 3 things. The length of the major axis, the length of the minor axis, and also the focal length. The focal length is just C. So take a crack at that. And if you have any color requests, let me know, because I'm getting bored of my colors. And let me know when you finish.
still have to multiply by a common denominator?
You shouldn't need any common denominators or anything like that. But this equation will be important. By the way, I never told y'all I dyed my hair purple.
Wait, what?
Yeah,
You did not.
I sure did.
Prove it.
I need a picture in the chat.
I mean a picture in general.
Let me see if I can acquire a picture. My hair has been blue and green before in the past.
Huh. Whenever I said prove it, I thought of that one Eric Andre moment whenever it was like them making fun of Scientology and they're like, prove it. Take a poop and turn it into wine.
Let's see if I can get a picture for y'all later. Are we all done with this? I'll assume that's a
Yeah.
yes. So, this 128 is going to be a squared, and this 36 is going to be b squared. So let's quickly find that. B must be 6, so the length of the minor axis is 12. And then C, let's find a squared really quick. Well, a is the square root of 128. 128 you can divide by 4, so that's 2 root 32. That's a, 2 root 32. So the length of the major axis is 4 root 32. And so, now we need to find...
Wait,
what's up?
can't 32 be divided by 16?
You're right. So 128 is divided by 64. It's 2 root 8. 2 root 8. A is 2 root 8.
But 8 can be divided by 4, and 4 is a perfect
No, it's 8
square.
root 2. Oh, I'm trying to do it all in my head. I need to slow down. So 8 root 2. Because 128 is 64 times 2. So that's how you get 8 root 2. Cool. 128. So that means that the length of the major axis is actually 16 root 2. Excellent. Why do you multiply by 2 to get the major and minor axis? Is that your question? Yeah. So let's look at the major axis. The major axis is that, and A is only the distance between... Cool. Wonderful. So now that we have A and B, we can find C. So A squared equals B squared plus C squared. I don't need to square that. It's already over there, isn't it? So 128 equals 36 plus C squared. So C squared is 92. So C is going to be the square root of 92. 92 is divided by 4 to get 2 root 23. I know this for a fact. So the focal length is 2 root 23. On the homework, you will also be asked to find the foci. Well, how do we do that? We know the focal length. So the foci must be this many units away from the center, which is 3, 2, along the major axis. Foci are always along major axis.
Okay, so can you explain what the foci is again? Like,
Yeah.
is that just the focus point?
Yeah, those are the foci is the two foci is plural of focus.
Okay, okay.
Yeah. So if this is the center, then the foci needs to be 2 root 23 units away from the center along the major axis. And the major axis is the y-axis because it's vertically oriented. So I need to add and subtract 2 root 23 from the y-coordinate. Is this good? Because y'all have a couple questions on this. Do you understand how to actually find where the focus is?
Do we just write it like that?
Yeah.
Okay.
Cool. I got one last thing for y'all. I want to show you. So just like we did with circles, we may see sometimes an ellipse that is not in standard form. Plus 9y squared plus 250x minus 36y plus 436 equals 0. So same story. The ellipses and circles are so closely related in equations, all we have to do is just like with the circles. We complete the square on the x's, and we complete the square on the y's, and we'll be good to go. So let me put the x's together. First of all, 25x squared plus 250x, and I'll leave space, and let's put the y's together. I get 9y squared minus 36y, and eventually I need to get equals 1 on the other side, so I'm going to move 436 over. Before that was just 1x squared. We have to deal with that 25 now. The way we deal with that is just by factoring out 250 divided by 25 is 10x, and then plus 9 quantities y squared minus 4y equals negative 436. So let's complete the square here. If I want to complete the square, 10 divided by 2 is 5. Square it, you get 25. If I want to complete the square here, negative 4 divided by 2 is negative 2. Square it, you get 4. But we didn't just create 25 and 4 units. We actually, we actually created 25 lots of 25 units and 9 lots of 4 units. So I need to add 625 from completing the square on the x's and 36 from completing the square on the y's. So I get equals 225. Negative 436 plus that. So I'm left with, and I can finally factor, I get 25 lots of x plus 5 squared. Remember, keep the sign, divide by 2, plus 9 lots of y minus 2 squared. Keep the sign, divide 4 by 2. This is what we've...
That 6 look a little bit better on 436.
Yeah, you bet.
Thank you.
It's terrible. Oh my goodness.
Perfect.
Okay, so last thing we need is just 1 over here. So we have to divide everything by 225. So 25 divided by 225 is actually 1/9 x plus 5 squared. And 9 divided by 225 is actually 1/25 y minus 2 squared equals 1. So notice the reason this happened is usually 225 is actually 9 times 25. It's kind of coincidental, but this happens a lot with ellipses. And so the 1/25th, when you divide by 225, you're actually dividing by 9 times 25, so you get 1/9. And the 9, when you divide by 9 times 25, you get 1/25. It's going to be small, but here it is. x plus 5 squared quantity over 9 plus y minus 2 quantity squared divided by 25 equals 1. And from this, we could tell everything about the ellipse, right? Any questions with this process? You guys know how to complete the square. All right. Good work today. The homework is a worksheet. It's already up there on the portal. Should be. And have a great day. The weather's awesome out there. So thank you, y'all.
Thank you, Mr. Strickland.